Welcome back to a new data science project video. In this project, what we are going to do is we are going to do data analysis, data cleaning, feature engineering, data visualization. We are going to train machine learning models, and we are going to create a web app for the users to predict house prices with the inputs they have. We have a data set about house prices, and we are going to try to predict their prices with the features it has. I'm going to leave the datasets link in the description of this video. You can download the dataset and code with me in the video, so you can add this project to your data science portfolio. You can see the final version of the web app that we are going to create in the screen right now, and we are going to code all the process together. Let's start coding. Here is the data card of the dataset that we are going to use in this video. We are going to use the dataset of house prices India, and I'm going to leave this link in the description of this video. So let's read the about section. This dataset contains detailed information on residential property prices in India. It includes features such as the number of bedrooms and bathrooms, living and lot area. We don't need to read them, we are going to just check them out in the VS Code. This dataset is ideal for real estate market analysis and predictive modeling, providing insights into factors influencing property prices across different regions in India. Okay, great. Let's quickly check the columns. So we have 23 columns, and there are ID, date, number of bedrooms, bathrooms, living area, lot area, number of floors, waterfront present, number of views, grade of the house, area of the house, area of the basement, built year, renovation year, postal code, latitude, longitude, living area, renovation, lot area, renovation, number of schools nearby, distance from the airport, and price. So this is going to be the thing that we are going to predict with regression models, and you can just download the dataset from this section, the download button, and you need to put this file in the same directory with your Python script or Jupyter notebook, or you can just use it in different folder. You just need to give the exact path. So if you're going to code with me, just download the dataset, and if you're not, if you are only going to watch, let's get to the coding part. So here I am at the VS Code screen, and you can see my CSV files in here. You can just download it and put in the same destination like that. You can also use PyCharm, Spyder, Google Colab, any code editor that you want. I prefer VS Code. And I'm going to start by creating a Jupyter notebook at the first place. I'm going to give it a name like notebook.ipynb, and then I'm going to select my kernel here. I'm not going to use anything like virtual environment, etc. I'm not going to make it too complex. So what I'm going to do is, at the first place, I'm going to start by importing the pandas and then loading my data. So for that, I'm going to come to my files directory explorer section. I'm going to copy this name, and I will say pandas read CSV, and I'm going to give this name in here. And what I'm going to do is I'm just going to make this run at the first place, and we can see that it can be loaded successfully. So what I'm going to do is I'm going to save this at something like data, and from now on, whenever we call the data, we are going to get our data set. Great. So we can use .hat for checking the first 5 rows and getting a general information about the data set. We can also use tail for getting the last 5 rows. Also, you can specify this number, like if you say 3, you are going to see the last 3 rows. If you say hat 3, you are going to see the first 3 rows. And I'm just going to leave it defaultly, and I'm going to have 5 rows. So as we can see from here, we have 23 columns, and let's quickly check them. So I'm going to call data.information for seeing the column names and their data types. Also, we can go like data.columns, but in this way we are not going to see the data types, so we can directly go like that. We can see that we have ID, date, number of bedrooms, number of bathrooms, living area, lot area, number of floors, waterfront present, number of views, condition of the house, grade of the house, area of the house, area of the basement, built year, renovation year, postal code, latitude, longitude, living area, renovation, lot area, renovation, number of schools nearby, distance from airport, and price. Okay, great. So it seems like we all have numeric values in our X side, also Y side in our data. So what I'm going to do is I'm just going to quickly call data.describe for getting the numerical summaries of the dataset. So here it is. We can see that on the ID side, we can see we have scientific numbers, we have date, number of bedrooms, number of bathrooms. I'm not interested in all that. I'm just going to check the statistics for the price side for having information. So we can see that these are all scientific numbers, by the way. How we can transform them is you can just use, since this returns a pandas series, you can say reset index, and then you are going to get a data frame like that. And at the price side, you can do like price, and you are going to get this like that. And you can say round, and then you can use 2 like this. And with this, you are going to get the actual numbers. So we can see that minimum is 78,000 and maximum is 7,700,000. And we can see the statistics like mean, standard deviation, and I think that's great. Okay, so I'm just going to make this delete and I'm going to leave it like this. So great. Also, we don't need to select the price like that. What we can do is, if you want to see this count, mean, standard deviation still, we can use like stats, and it's going to be equal to that. And then I'm going to say stats price is going to be round stats price to 2, and I will say capital letter P. So whenever I call the stats again, we are going to see that we can see the index and we can see the non-scientific number. Great. So let's continue. I'm going to check if we have any NA values in our data set right now. So I will just call the data, and then what I'm going to do is I will say is NA, and it's going to return me booleans for each cell, and then I'm going to use that sum, and this will give me the column wise NA counts like that. So we don't have any NA values in our data set. Great. We can also check the total from that sum. If we use that, once again we are going to get the total sum with 2 sums in here. Great. So since we don't have any NA values in our data set, let's continue with checking duplicated ones. So for that we will say data.duplicated, and we are going to get booleans again, and if we use that sum, we are going to get the total. So we don't have any duplicated rows in our dataset. Great. If we had NA values or duplicated values, we just need to use for NA, let's comment it like that, for NA values, we need to say data drop NA, and we need to set it like in place equals to true. And for duplicated ones, for duplicated values, I'm going to say data duplicated, and I will say not duplicated, drop duplicates, and I need to set that one with in place equals to true too. So with these comments, you can delete the duplicates or NAs. Also, there are other ways of dealing with these values, like you can make slight changes on duplicated ones, or fill the NA values with mean, or you can use interpolation, but I'm not going to talk about all of them in this video. And next I'm going to call my columns, and what we can do from here is I will call the data again. So let's call the head from here, and let's group our data by condition of the house and get the average prices from that. So I will say data group by, and I'm going to say condition of the house, and I will say price like that. I will use mean. So we can see that with a single difference in here, if the condition of the house increases, the price increases. Also, you can sort this in the descending order, like I will say sort values, and it's going to be ascending false. We can manipulate this in the way that we want, since this returns a pandas series. So it's sorted in the descending order right now. And let's say we want to create a bar plot from this. We can directly use like dot plot, and we can set the kind as bar, which is going to let us have a great looking bar plot. So we have the bar plot, and you can change the order of this. Like I set the ascending equals to false. If you say true, it's going to give you the ascending order. And let's say false again. Let's say you just want to plot the top three. So after this ascending thing, you can use head 3 for getting the top 3, like this. But I'm not going to do that. What I'm going to do is, I want this plot to be prettier. So I will just import matplotlib.pyplot as plt. And then I'm going to give the y label title. And I will use plt.show for not displaying that. So after that, I will say plt.title. And I will say condition of the house versus price, and I will say plt.ylabel, and I'm going to give mean price at the y label, and I will use plt.show, and I think it's going to look pretty better. Great. Also, we can change the x label like x label, and I will say condition of the house. Great. So we have this plot in here. Next, I'm going to call my data, and then what I'm going to do is, I'm just going to check all of the columns once again. Okay, let's get to the modeling side. I will say data.columns for picking from them. I'm going to pick for the x side. I'm going to pick, by the way, we can select the columns like with 2 brackets. Let's say we want to take the number of bedrooms and number of bathrooms. If we call it like that, we are going to get these 2 columns, and this is how I'm going to filter out the x and y. So y is going to be 100% is going to be price. So I'm going to call data price for the y, and for the x side I will take like data. I'm not going to create a too complex model, and I'm going to just train a tree-based model. I'm going to train tree-based models, so I'm not going to do any kind of scaling operations, since in tree-based models you don't need them. So I'm going to pick like, for sure, number of bedrooms and bathrooms are important, so let's include them. I'm going to make copy paste, and what we can include else is we can include living area like this, and then I'm going to include, let's say, condition of the house, not necessary. I think maybe we can include that, since we saw a correlation with the price. And what else we can do is, I'm not going to include build here. What we can do is, I think it's enough. We can also include number of schools nearby, distance from the airport, etc. But I don't want it to be too complex, but let's also include the number of schools nearby. And I think these are pretty enough. So let's call our x right now and see what we have. Okay, we have great columns. And at the y side we are going to have the price. Okay, so the next step is going to be, I'm going to use train test split from scikit-learn. So why do we use train test split? With train test split, we do split our data as training and testing sets, and we do that because with the training set we train our models, and with the testing set, since model don't see it in the training, it's going to be like our unseen data, new data points, and we are going to evaluate the model's performance with the test set. So we are going to have 4 features: xtrain, xtest, ytrain, ytest, and we are going to train our model with xtrain and ytrain, and we are going to test them with X-test and Y-test. So let's do that. I will say from scikit-learn.model selection import train test split, and then I will say xtrain, X-test, Y-train, Y-test, and it's going to be train test split. I will give X, Y, and the test size is going to be 0.2, which means that your 20% of your data is going to be in the test set and 80% is going to be in the training set. So if you have like 1,000 data points, 800 of them are going to be training set if you set this to 0.2. So I'm going to just call the data.shape for seeing the general shape of our data. So we have this amount of rows, and let me quickly take that from here and multiply it with 0.8. So this is going to be number that are going to be in our training set, and this is going to be the number for the test set. We can also test it like xtrain.shape, and you will see that we have this 0.8 multiplied number in here. Great. We also saw that, we observed that it rounded it backwards. Great. So since I'm not going to train any type of different models than the tree-based ones, I'm not going to do any type of scaling operation like standardization or normalization. But if I were going to do that, I was going to do export the scalar that I used on the training set, and I will use that scalar in the Streamlit UI part. So in the other projects you can also check them. When I do scaling and I do a user interface application or I do an API endpoint creation, I use the same scalar where I use on the training set. So you need to use different scalars for the training and testing set, otherwise you are going to have data leakage on your model. Great. So we can continue with the models. So I'm going to just import grid search firstly. So I will say from scikit-learn.model selection import grid search cross-validation. Grid search let us try different parameters for the models. Like we have a lot of different parameters for machine learning models. For example, we are going to train a decision tree regressor, and we are going to have features like splitter, criterion, max step, and these parameters can be optimized for getting better predictions. So that's what we are going to do with the grid search. We are not going to train the base models, and we are going to try combinations for getting the best parameters. So let's start with decision tree. I will say from scikit-learn.tree import decision tree regressor, not classifier, since our problem is a regression problem. And I will say parameters grid is going to be, these are going to be our parameters, possible parameters for the model. So it's going to be a dictionary, let's say criterion, and it can be mean squared error and Friedman mean squared error and mean absolute error. And then I will say splitter, and it can be best in quotes, best or random. And I will say for the max depth side it can be, let's say none, 10, 20, 30, 40 and 50. And we can say for the minimum sample split side it can be 2, 5 and 10. And for the minimum samples leaf side it can be 1, 2, 4. We can also extend them, but I'm not going to do that. You can just extend this list for trying more parameters and getting better performances. So we are going to initialize the decision tree regressor right now. I will say tree model, and it's going to be equal to the decision tree regressor. Then I'm going to initialize the grid search object like grid tree, and I'm going to give estimator is going to be tree model, and it's going to be the, for the parameter side it's going to be parameters grid. Also, I'm going to say grid 3, and I will use grid search cross validation like that for initializing it. Then we are going to train our model using the training data we have. I will say grid 3 dot fit, and I'm going to use my X train with Y train I have. So I'm going to be re-recording when this model is trained. So it's trained, it returned some stuff. Let me read. I think it's not a problem. Okay, so we trained our model. Now what I'm going to do is I'm going to get the best parameters picked from this parameter dictionary. Like, I'm just going to clear this output. I don't really care that error, and I can see that normally we can fix for getting more fits. Like, we trained our model with 1,000 of our data, but it's not a problem. So out of these parameters, let's see which one are picked as the best ones. Like, we are going to use best parameters, and criterion Friedman mean squared error max step 10, minimum samples leave 4, minimum sample split 10, and splitter random. So next step is going to be we are going to get the performance of this model. So how we are going to do that is we are going to get predictions on the .predict x test testing set, and we are going to get an array like that. And what we are going to do is we are going to store them like 3 predictions, and it's going to be grid 3.predict. And at the next step, what we are going to do is we are going to import from scikit-learn matrix, import mean squared error, and I will say mean squared error and 3 predictions. Let's give the 3 values firstly, y test and 3 predictions. And here is our mean squared error. So this is a pretty big number, and this can be depending on your case. Like, maybe this can be a good number, it's not, but maybe in some cases it totally depends on your case. So decision tree regression, we didn't get a pretty good performance. Let's also try. Let's firstly, before trying another tree based model, let's go with linear regression and see how it performs. So if that performs pretty great, then we don't need to do anything else. So I will say from scikit-learn.linear model import linear regression, and linear regression I will initialize it like that. Then I will fit X train with Y train, and then I'm going to say predictions linear regression is going to be linear regression.predict x test. Then I will say mean squared error, and I will say predictions linear regression. So actually we need to give 2 y true, so it's y test, and now we are going to get our mean squared error. Okay, they are same, so it's not lowered, but I don't really care about that. I'm just training a model. Like, you saw that at the feature selection side, I didn't really look for anything back on the correlations. We are just training a model and serving it with user interface. So let's also check the mean absolute errors on the models and compare them. Mean absolute error, because we normally look on the mean squared error side, we use numpy.square root. So I'm just going to go with mean absolute error like that, and our mean absolute error in here is 158,000, and I will get the mean absolute error on here too. It's 162,000. Okay, so let's continue with the random forest regression, our next tree based model. So for that we are going to say from scikit-learn.ensemble import random forest regressor, not classifier, and then we are going to say RFR model is going to be random forest regressor. It's going to be initialized on the RFR model. Then I'm going to define the parameters grid RFR. It's going to be like, we can give max depth, and it can be 5, 10, 15, Then I'm going to give number of estimators 2, 3, 4, 5, 6, 7. Let's continue until 10, and these two enough. We can also give other features, but we gave a lot on the decision tree. I'm not going to do that. On here I will say grid RFR. I'm going to initialize the grid search cross validation RFR model with parameters grid RFR. Then next we are going to use grid RFR.fit, and we will give xtrain with ytrain. So after, actually something is happening, let's quickly fix that. It's giving a column vector y was passed. Okay, so we are going to fix that by dot values dot rival. It's not going to raise that error right now, yeah, as we can see. And I'm going to re-record when this model trains. I was going to say that, but we trained our model. Great. So let's see the best parameters picked from our model. Best parameters, it's 5 for the max step, 10 for the number of estimators. So how we can optimize this is, you see on the max step side 5 is picked, so you can go with the lower values of 5 on the max step side on this list. Like you can also put 3, 2, and on the number of estimators side you see 10, so you can just extend this list on the 10 side. Like you can add 11, 12, 13, and you can just delete the previous values. Great. So at the next step we are going to get predictions with our model. So I will say RFR predictions, and it's going to be grid RFR dot predict, and I will say x test. So after that I'm going to call mean absolute error. I will give y test and RFR predictions. So we are going to have 154,000. Great. So I think this one was the best one. Yes, better than linear regression and better than decision tree. Yes, yeah. Okay, so we are going to continue with random forest regression. Once again, we didn't try to optimize the model. You can do that by selecting different features, trying out different models, scaling the features, but I didn't prefer that. So next step is going to be exporting this model. So for that we are going to use joblib. I will say import joblib, then I will say joblib.dump, and we are going to dump our grid RFR with the name, let's say model.pickle. So it says this means that it's exported successfully. Let's look at the Explorer. We can see that model.pickle file, our pickle file that we are going to use in our app. So we are all ready. We did our analysis, then we trained our model, and we exported it successfully. Now it's time for creating the Streamlit prediction application creation. So I will say, at the first place, what I'm going to do is I'm going to call the x.columns, and I'm going to copy this list because we are going to take them as inputs in our app. I'm going to say app.py, and I will just paste them like order of x, and I'm going to paste this. So I will also use that. We are going to delete that, it's not a problem. We created our app.py. Let's start creating our app. So let's start with imports. We are going to import Streamlit for sure. And then let's close this Explorer, and let's continue with closing this notebooks, save, and pick a file. Okay, let's continue to code our app. Then what we are going to do is we are going to import joblib, and we are going to import numpy as empty. Great. So let's start by giving a title. We will say streamlit.title, and let's give it a title like house price prediction app, and let's give it a divider. I use dividers a lot in Streamlit apps. I think that they make apps look really better. So we are going to write a description like this app uses machine learning for predicting house price with given features of the house. For using this app, you can enter the inputs from this user interface and then use predict button. Okay, so now we are going to create that button and inputs. So let's start by taking the inputs firstly. I will say Streamlit.divider for adding another divider. Then I will say, let's say we are going to take firstly the number of bedrooms. So I'm going to say, let's say like bedrooms, and it's going to be like Streamlit.number input. Then we will say number of bedrooms, and let's give it a minimum value of 0. I will fix the typo there, and let's give it a value of default 0. Okay, so then I'm going to say number of bathrooms. So it's going to be number input again. I will say number of bathrooms, and I will say minimum value is going to be 0, and the base value is going to be 0 on this one too. And then we are going to say, let me quickly check what kind of values living area takes. So on the notebook we can see that. Let me quickly find an xcol. So I think we can check it in here. Living area, this around 2000. Okay, so we can give it a value like that. So again on the app I will say the third one is living area. So living area is going to be Streamlit.number input living area, and let's give it a minimum value of 0 again, and this time I will give value of 2000. And then I will say condition of the house. So condition is going to be Streamlit.number input condition, and I will give minimum value of 0, and I'm going to give value of, let's say, basically 3. And then I'm going to say number of schools, and I will say Streamlit.number input again, and I will give number of schools nearby, minimum value 0, value 0. Okay, then we will use divider again, and after these inputs what we are going to do is we are going to create a button like predict. But firstly, before that, I'm going to say model is going to be joblib.load model.pickle. So the file in here. So we are going to use predict method from that. And then it's not going to appear on our app. We can place it in anywhere that we want it. Okay. Then I will say X is going to be bedrooms, bathrooms, living area, condition, and number of schools. This is going to be the X that we are going to be using on the prediction. And then I'm going to say predict button is going to be Streamlit.button predict. And if this button is used, if predict button, firstly I'm going to write the else statement of that. Else, just write Streamlit.write, please use predict button after entering values. And if button is used, then we will say X array is going to be numpy.array, and we will give X. Then we will say prediction is going to be model.predict, and we will predict the X array. Then I will say Streamlit.write price prediction is, and I will give, let's use an F string in here, F, and I will say prediction like that. and I think it's cool right now. Also, we can add an effect when the button gets used. We can make balloons appear on the app. So what I'm going to do right now is I will say save all. Then after saving my file, I'm going to go to terminal and I will say Streamlit run app.py, and let's see if our app is working. I'm going to record my browser right now. You need to go to this address. Let me quickly show you. This one with the port 8501, 192.168.1.101, port 8501. And when you go to this address or this one, you are going to see the browser screen that I'm going to show you right now. So here's our app, title, dividers are these things in here, and here's our description. This app uses machine learning for predicting house prices with given features of the house. For using this app, you can enter the inputs from this UI and use the predict button. Okay, let's do that. Number of bedrooms, let's say 2. Number of bathrooms 1. Living area 2000. Condition, let's say 4. Number of schools nearby is going to be 1. And I will say predict. So we get the price prediction here, and it's 486,000. Great. So our app is working nicely. Let's make a little change on this appearing thing here for making it look better. So from here, I'm not going to close my app. I'm just going to come to here and I will say prediction. I will take the first element of this and then I'm going to say point to floating. Actually, I think we need to change its place like this, and I'm going to save like that. So let's go to the app once again, and you can see at the right upper side on the browser it says source file changed. So I'm refreshing up and I will enter random values like this again, condition 5, number of schools nearby 1. I will say predict and we can see the number displayed. Really beautiful this time with comma and to floating. Great. So we can change these values and get predictions as we wish. So I will do this, and here's our new price prediction. Great. So let's summarize our code and finish this video right now. So in here, what we do is we are importing our libraries. Firstly, we import Streamlit, JobLib, NumPy, Streamlit for the entire UI, and JobLib for loading our model and its methods, and NumPy for creating an array. Then we save our model, we give our app a title, we use dividers for making it look better, we write a description, we take the number inputs from the user, then we create X, and then we define a button as predict, and we write an if statement. If button is not applied, then we say please use predict button after entering values, and if the predict button applies, we make balloons appear. Then we create an array, we get a prediction with that array, and we take the first element from that for getting the exact number. Then we write a f string with point to floating, which makes us have a beautiful looking number. Great. So I think that was all for this video. Thank you for watching. I'm going to go to the outro right now, but if you come to here, I will be really happy if you can leave a like. Thank you. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Data Science Projects where I have more than 20 data science projects with their datasets on that playlist. You can just reach to it from the cards of this video or the link in the description. See you in the next tutorial. Have a great day.